This is an introduction to the Metal assembly language editor for the Commander X16. Now, there's been a lot of changes to this program. I had a couple of months with absolutely nothing to do this year, so I converted version 1.1 to version 1.2. Version 1.1 was build number 77. You can see it's just a call to assembly language. Version 1.2 is build number 655, so there's been a lot of changes. I'm calling it the Metal editor because it's as close to the bare metal as you're going to get, and it relies very heavily on metadata, and the AL part stands for assembly language. You can see it's changed to the MIT license now, which means you can use any of this code in this program in your own programs. You can use this program freely. You can use any of this code even in commercial programs if you want. Just leave the MIT license somewhere. So we can press any key here, and you can see there's a message bar at the top, which in this case it lists that we're in mode 1 and in low RAM. It shows us our file start and our file end. This message bar changes depending on where you are in memory. If we go into banked RAM, now you can see it lists which bank you're in, and B end, it's similar to the file end, except it's for this particular bank, and it's used in editing when you want to insert or delete, but I'll get to that in another video. I'm going to change this bank just by typing bank and go to bank 0. This is system RAM. Now it's very dangerous to change anything in this system RAM, so I've protected it. It's being used by BASIC, it's being used by the file system, and you don't want to inadvertently change values in this bank. Similarly, if you go to, say, the stack, you don't want to be changing any values in the stack accidentally. If you're going to be changing values like this, you want to be doing it on purpose. So I've put tame in there so that you can't inadvertently change this. Same with memory mapped IO. If we go into memory mapped IO, this is also in tame mode, and you can change this if you want to by typing wild. Now the safeties are off and you can go ahead and change values in here, but again, this can cause unexpected results to your display, that sort of thing. So we'll just go into tame mode for now. I'm going to keep exploring a little bit up into ROM, and again this shows you what bank you're in. If you want to change to a different ROM bank, you just say bank 4 whatever, and it tells you which ROM bank you're in. This one's the basic bank. If I go bank 3, it's the GEOS bank, and so on. If I go to A000 again and change bank to FE, this is the editor. It's another protected area of memory, and you can see that it's trying to interpret all of the code on this page as assembly language code. Anywhere that it sees something that matches with a label that it's got in its memory, it says, well, it's implied that that's a label, and so it displays that, but it's displaying it in reverse characters. Now to see the actual metadata that's attached to this, we have to switch our metadata files. And we'll go to editor, and now it loads up all the metadata that's attached to this file. Now the way all of these files are stored in memory is the way it's displayed in the middle column, that reverse character column. That's how the program's actually stored in memory. It's stored as compiled code. And as you type it, it's interpreting it into assembly language, into the ones and zeros, and it's storing it that way. The only decomiled code is what's being displayed on the screen at the time. So basically the only decomiled code is in Vera. It's interpreting all of this as it displays it. So the only place that this code here exists with LDY, LDX, and all that is on the screen right now. Everywhere else it's stored as assembly language code, and it's stored separately as metadata for things like comments. So let's clear out our metadata here. META, yes, and we'll go back to the default metadata, and as you can see, it's just decompiled code there now. Let's go back to Fend, and we're going to type a quick hello world program. I'm going to need two labels right off the bat, so I'm going to set label. Labels can be any 4 characters that start with a letter. The other 3 characters can be letters, numbers, a collection of half a dozen symbols, and as long as it doesn't correspond to a hexadecimal code like beef, yeah, it won't take that as a label, and you cannot use a label that's already been used. So we're going to set another label here, Zort. Now Zort, we're going to make this a string. To switch modes, there's 5 different editing modes. You just hit F1 through F5 to switch modes. So I'm going to go straight to mode 5, character mode, and type in a quick string here. Oh, RLD. That's 13 character long string. Hit F1 again to go back to mode 1. And I'm going to set another label here right after our string. And we'll go back up to narf. Now we said Zort was a 13 character string, STRI0D. Okay, now it displays that in a better way. And if we go to mode 4 here, single byte mode, you can see that each byte is displayed both as hex and as the individual bits. Now I want a clear screen character to start the narf string. And if we go F1 again, we can say that narf is now a string of 14 characters, 0E. So what point is going to do, this subroutine is going to print the string that's associated with Zort. So we'll load X with the low byte of Zort. We'll load Y with the high byte of Zort. Load A with the length of Zort. I just hit the letter L there. If I hadn't hit L or less than or greater than or the octothorpe, it would have been expecting hex characters instead. And now we'll set another label here, PRST. This is going to be our print string subroutine. So let's put a comment on it. And we'll store X and Y, the low byte and high byte, in 0 page. And we will transfer that file length, or the string length, to X and load a counter with 0. Now we can load a indirect index 0 page comma Y. A lot easier just to hit a minus sign. And we're going to call the kernel character out subroutine. Now we can increment our index and decrement our counter, and as long as our counter is not equal to 0, we want to loop back to 0833. Now we could just type in BNE number F7 and it would do that, or we could type BNE A 0833, and either way it's the same, it's exactly the same. It's the only difference is the way it's displayed. In mode 1 it's displayed this way, mode 2 it's displayed that way. So that's the end of our print string character, and now anytime we call point, it'll say hello world. So we want to set another label here, HELO, which will call narf and then call point 9 times. Or it'll print narf and then print Zort 9 times by calling point 9 times. So we'll load X with the low byte of narf. We'll load Y with the high byte of narf. Load A with the length of narf and call print string. Next we're going to load our accumulator with a counter 9 and store that in 7D and use 0 page 7D as our counter. And we'll just call point and decrement our counter. As long as our counter is greater than 0, loop back to calling point. So now if we execute hello, there we go. Well, that's very nice. Let's save this. So we'll save hello.prg. Are you sure? Yes, file saved. Okay, now let's say that we wanted to have an extra command in this loop here, that we wanted to call another subroutine. So let's insert 3 bytes. And now we can call another subroutine. We can call point a second time. So exec hello there. Now it's 21 times, or 19 times instead of 9. Well, let's say we didn't want to do that. Let's delete 3 bytes. Okay, no problem. Let's say we wanted a different string. Let's say we want a string that's a little longer here. So we'll go into the middle of that and we'll insert 6 bytes. Go back here. So, well, maybe we say that's a little dark. So we'll go F5, we'll go back down to here, and we'll delete 6 characters, and exec hello. And as you can see, inserting and deleting, it adjusts string lengths, it adjusts the locations of labels, it adjusts branches, it does all of that automatically for you. So let's quit, and there we are. If we load hello, we're back into the editor, but we've got our hello program and all of the hello metadata. So that's basically the start of it. There's a lot more. I'm going to be having a lot more videos coming out soon, but this is just the introduction. So have fun playing with the Metal editor.